over some charts and graphs, some of which you have seen, some of which you have not. The stem and leaf plot is one maybe you have not seen, and the stem and leaf plot is a pretty, in mathematical terms, elegant idea because it shows you a pretty nice picture with some pretty easy paper and pencil work. If I had a set of data, and I don't know what these represent, but you can imagine maybe they're ages of people that have a certain characteristic, okay? And they go from 21 to 45. I got 225, so 26. Well, a stem and leaf plot is just a quick visual representation of that data. And what I do is I make a stem out of kind of the first part of the number. And then the leaves are all, in this case, the units placed. So I had 6 observations that were in the 20s. And the way I construct this is I always say, here's the stem, the 20s, the 30s, the 40s, because you can see that's the range of the ages that we're talking about. And then I order these from lowest to highest so I can actually get more organization of the data. And I make the stem and the leaves, and right away, of course, you can step back and you can say, well, that little picture, I noticed that there's mostly 20s, and 45 is only one in the 40 category, okay? It's just organizing the data so visually you can get a picture of what the distribution is. And certainly I can get a better picture of that distribution, organizing it that way than just looking at this line of data. That makes sense to everybody? And it's not tricky. Now, the advantage of that is I get a quick snapshot of how the data is distributed, how it's laid out, maybe where the bulk of the data lies. I wouldn't want to do it with 1,000 data points. And there's not a lot of software packages that I know of that make stem and leaf plots, okay, because it's mostly a back of the envelope paper and pencil drill. Now, the one thing that's missing here that you should never have somebody ask is, what the hell is that chart about? So you got data, but you always ought to have some sort of key or note. And if you were to make that stem and leaf plot, you might put a key on it that says, to read that chart, and if you go to 3.6, that means, I don't know, 36 years old, or whatever it means, in other words, what the data means. But you ought to provide context. Somebody should not look at your chart and say, but that's a really nice picture, but I have no goddamn idea what I'm looking at. Okay? It doesn't make any sense if you don't tell the reader that this data is about something. So there ought to be a key there somehow. Questions on the idea of a stem and leaf plot? There, I think, is an example here in your textbook and in the slides, another example. Number of text messages sent. It's a longer and a bigger stem and leaf plot. Take a look at that example, and you can see there that they have the key if you look up there. Now, another way to organize data is what we call a dot plot. That's a less creative name because it's just made out of dots. Right? A dot plot is a bunch of dots. And all the dot plot is, if I had data that was in whole numbers, and that's the same data set, and I just drew a number line, I would put a dot for each data point that I had. And to me, that's a pretty lousy looking chart. It's really not, it doesn't say much. It looks like the number line with a bunch of dots on it. I know it goes from 21 to 45. I got two 25s, I got two 36s, but it doesn't. The stem and leaf plot on that data looks a little nicer. It gives me more sense of where the data is distributed. But if I had a lot of data, maybe a dot plot would be good. But all it is dots above the number or the measurement. And so, easy to make, but if I had a lot of data, maybe if I had more data, this is more meaningful. Whoa, that's the bulk of the data here, number of messages sent, the bulk of it is between 115 and maybe 130. I can see that this is a really low value because it's way there to the left. I can see that 160, 155 are pretty high. But with more data, the dot plot seems to be conveying more information. And they're just techniques, okay? That's all they are. They're just trying to understand the data by pictures. Maybe those two you haven't seen. I think maybe several of these others you probably have seen. How many people have seen a pie chart before? A pie chart is just a circle, right? And the circle typically is divided up into different sections that represents the slice that a category accounts for. So if we actually have data that says we're looking at a bunch of people here, and then all of these people are the number of, in thousands of folks who actually in 2007 earned these degrees. Well, how would I make a pie chart? Well, I'd have to say, well, okay, so 728,000 out of whatever the total is there earned an associate's degree in 2007. So I'd have to sum everything up. I'd have to figure out what the percentage was for 728. Turns out it's 24%. And I can then make a pie chart, probably you've seen before, that says, here's the slices of the pie based on what percentage each of those categories accounted for. Questions? Does that make sense? Anybody remember a compass and a protractor? Yeah, me too. With some cynicism, I suppose. Okay, but you know, if you actually had to make a pie chart and you had a compass and a protractor, you'd have to figure out how big these angles are before you could draw the slice of the pie. So if the associate's degree is counted for 24% of all of the degrees, then you'd have to say, well, okay, so 24%, how big is that angle? How do we figure out how big that angle? Well, it's 86 degrees. Why is it 86 degrees?
360 degrees in a circle.
There's 360 degrees in a circle, and I take 24% of those 360 degrees, and I make that angle, and but nobody does this anymore. I mean, you know, you go to Excel or you go to some software package, you just put in 24%, 51%, 20%, and it makes a nice circle for you. Now, you can really screw yourself up, though, if these don't add to what?
100%.
They got to add to either 1 or 100%, right? Because you got one pie that you're slicing up, right? So if you go to a software package, if you go to try to make a pie chart and you say, oh, this is great, I got, you know, 118%, that's not a pie chart, okay? You can't have a pie that's 118% and all the parts add up to, you know, that's more than there is. Or if it's less, if it's 92%, then you're a slice of the pie missing. But these are really great for qualitative data, right? Qualitative data. Remember that idea of qualitative data? Nominal data, right? Just categories, right? That's what that is, okay? It's qualitative, nominal data. Associates, bachelor's, master's, first professional degree. Let's look at a Pareto chart. Pareto chart. Looks like a bar chart to me. Got a bunch of bars on it, right? Going up. Why do we call it a Pareto chart? Anybody have any idea? What's that?
Pareto invented it.
Yes, he did. A guy named Pareto invented it, okay? And he had a brilliant idea one day when he was looking at a bar chart, and he said, you know, it'd be a hell of a lot easier to read if you just put the highest bar on the far left, and they went down to the lowest bar on the far right. So you make a bar chart, and you say, well, it's pretty nice, but why don't I just put the biggest category over here and work my way down, because it's just easier on the eyes, and I can read it better, and right away everybody wants to know what the biggest category is, okay? So a Pareto chart is nothing more than a bar chart, where I think Mr. Pareto one day said, well, let me move that one over here. It's the highest one. It ought to have the featured spot. And so that's all it is. And we position it from highest to lowest. So if I actually happen to have something like causes of inventory shrinkage. Anybody work in retail? is shrinkage? What does your company think of shrinkage? You know what shrinkage is? It's the stuff that magically leaves the store. And nobody knows how it leaves the store and who is walking out with the stuff, okay? But, you know, all retailers have shrinkage, right? You go to Target, you go to Macy's, you go to even food stores. You know, they get in all of this stuff, and then all of a sudden, you know, they lose stuff. Shoplifting, you know, employees walk out with it, okay? Administrative error, they were supposed to get, you know, 25 items, they got 24 in the shipment, okay? But it's shrinkage, that's what they call shrinkage, right? And most companies, that's just the cost of doing business. Now, if you lose 10% of all your inventory that way, that's probably a good way to go out of business. But I think most companies, even retail stores, are probably 1% to 2% shrinkage. They just lose stuff. It just goes away. It disappears. So anyway, if there was a survey or if there was various categories of how shrinkage occurred, I could make a Pareto chart, and I'd put the highest down to the lowest. Now, it's interesting, I don't know if this is real data, but it's interesting that employee theft
No, it's the most common, they
is
say.
higher than shoplifting. And I think that is probably accurate, actually. That employees walk away with items, more items than they actually get stolen at the shoplifting thing. But that's a Pareto chart, okay?